So I'm just going to give like a perspective on the section formula. The way it has been derived is exactly how I would also have derived it. And I mean the way it is being done in the Tamil Nadu textbook, and with triangles and basically looking at similar triangles and weights. So I think what I would like to talk about is like a perspective. So if you have 2 points, right, the way I think about it is that if you wanted something, let's say you want it in the middle, then I think of like both these are pulling each other, pulling this point, or balancing is how I think about it. I really think about it like a seesaw. They have the same weight, and they are, so it gets pulled to the center. So if they have the same weight, and if this is this is x1, y1 and x2, y2, then the x in the center is being pulled equally by x1 and by x2, and so it becomes the average of it. So it's called a weighted average. Both of them have the same weight, right? And the y here is also the same. They have the same weight. Okay. But if I wanted a point that is, let's say, r is to 1, this is what they started with, right? That this is so much further than x1 and closer to x2, and if you had a seesaw, right, and you wanted to balance this, then this person needs to be so much heavier in order to be able to balance the seesaw. So that's how I have looked at it. I have looked at it as r2 is pulling it more towards him, so I would look at the x, this x, right, as r times x2, so this person is so much heavier, then x1, and then of course weighted average is the same. What is the total weight you have to put in the bottom? And the same way y is r times y2 plus y1 divided by r plus 1. So this idea of sort of weighted average and like of something pulling, if this guy is pulling and it has here such a small distance, he must have so much more weight. And then eventually when this extends, so when we extend it to m is to n, if m is bigger, this needs to be heavier. So the same idea, that it's m times x2 plus n times x1 divided by m plus n. Sorry, they are all x1. And m times y2 plus n times y1 divided by m plus n. So essentially this idea of a weight and a seesaw and how would you balance it. You would need this, if this is a smaller distance, this is pulling more, it needs to be a bigger weight. So that's where the m comes from, this weight comes here. So that's how I remember it and sort of look at it. And of course to derive it, what has been done as triangles and basically looking at what is the height and what is the width of the triangles is perfectly fine of a formal derivation.